Hey Pre-Calc students, welcome to today's lesson on graphing hyperbolas. So hyperbolas are actually two parabolas in one graph, okay? So the parabolas can open left to right or they can open up and down. So we'll talk about some of that stuff in a little bit. With every conic section we've studied so far, we looked at the general form and the standard form. So in the general form, you got to make sure that the general form contains both quadratic terms and that the coefficients have opposite signs. So quick reminder, some vocab. The quadratic terms are the ones that have the exponent of 2 for the variable. And remember, the coefficients have to have opposite signs, meaning one of the quadratic terms is going to be negative, the other one's going to be positive. So one of the biggest differences between ellipses and hyperbolas is that you're going to see fractions, okay? So that's actually a similarity, but the difference is that you're not going to pay attention to which denominator is bigger. Um, the major axis is actually determined, so this is really important. The major axis is determined by whatever variable does not have the subtraction. So in other words, whatever variable has a positive fraction, that's going to determine the major axis. Okay, so again, it does not matter which denominator is bigger. Okay, so you'll see that for these denominators we use the variable d and e. It really doesn't matter what variables you use. The point is that d or e could be bigger. Okay, so let's talk about the hyperbolas that open left to right. Okay, so you would call those horizontal hyperbolas. And if you notice in the equation, the um, this fraction is the positive one. It does not have the subtraction in front of it, and that's the x. So again, it doesn't matter which denominator is bigger. What matters is which fraction does not have the subtraction in front. So this is going to be your major. So your major for the horizontal parabola, the major axis is going to be the x-axis. Okay. Whereas in the other one, here, the y is in the fraction that's positive. It doesn't have the subtraction. So that means that this is your major. Your major axis is the y-axis. Okay, so your major axis is always whichever variable belongs to the fraction that does not have the subtraction in front. Okay. Okay, so some of the things that we're going to need in order to graph these are the values of d and e. Okay. So all of that in detail is explained right here below. So we're going to need those numbers, D and E. So obviously you're going to square root the denominators to obtain those values. And to draw these hyperbolas, we're going to need to draw these little rectangles. So those utilize the values of D and E. And we're also going to need these asymptotes, okay, which are called diagonal asymptotes. That determines how to draw the actual hyperbola. So the hyperbola is what you see here, okay, in black. That's the actual hyperbola, these two pieces. You see how they kind of look like sideways parabolas? Okay, so again, quick reminder, in order to draw these, we're going to need to draw this little rectangle, okay? And we're going to draw that rectangle by using the values of d and e, which are the denominators just square rooted. And these are pew, pew, the diagonal asymptotes. So in this one, on the right, since the major axis is the y-axis, since that fraction did not have a subtraction in front, that means it's going to open up and down. Okay. Okay, so let's get started and see how to graph these with specific numbers. So the vertices, remember, this is something that kind of pertains to what we talked about in terms of ellipses. The vertices are always on the major axis. The covertices are on the minor axis, okay? So remember that the major axis always depends on whichever fraction does not have the subtraction in front, okay? All right, one other difference. So I want to make sure you guys notice this down here. Major difference compared to ellipses. The foci are actually farther out from the center than the vertices, okay, which has never happened before. The foci were always inside the ellipse. Here, the foci are going to be farther away from the center than they were from the ellipse. So the equation's different. The equation is c squared equals d squared plus e squared. Now the diagonal asymptotes, we're going to find the slope, and the slope is actually going to come from the values of d and e. So this is the slope. You're going to use the values of d and e. Remember, slope is rise over run or fall over run. And then hopefully you guys kind of recognize this type of equation. It's called point slope form, where you plug in an ordered pair and the slope of a line, and that gives you an equation of a line. So we're going to be using the center for our diagonal asymptotes. That's what the h and k are for. So these two values are going to come from our center. And then again, m represents the slope. We're going to use the values of d and e. Remember, it's rise over run or fall over run. Okay, so graph each hyperbola, identify the center, vertices and covertices, foci, and asymptotes. Okay, so first things first, notice that the first fraction, it does not have the subtraction in front. So that means that your major axis is the x-axis, okay? So major axis is the x-axis. Now, remember that the d is always going to be the denominator that belongs to the major axis, okay? So this guy is going to represent the d. So I'm going to square root it, and that gives me 3. The minor axis is going to be this one. We use the letter E for that, so that's plus or minus 2. Okay, since they're asking me for the foci, I'm going to use my equation to find it. So the foci, we're going to use the letter C. Sorry, I'm having throat issues today. Okay, so c squared equals d squared plus e squared. We don't know what c squared is, but d squared is 9. E squared is 4. So you get that c equals plus or minus root 13. Okay? Feel free to put that in your calculator to see what the approximate decimal is. Okay, so the center of this hyperbola is 0, -3. Remember, you can identify that from the numerators of the fractions. So I'm going to go ahead and plot that point, 0, -3. It's going to be my center. Okay? Now what I'm going to do is I'm going to go back and think, okay, which one is the major axis? That's the x-axis, because that fraction that has the x squared over 9 was positive. It didn't have the subtraction in front. So this parabola is going to go open left to right. Okay? It's going to be horizontal. And that means that from the center, I need to go 3 units to the left and to the right, because that's the way the x-axis goes. Okay? So I'm going to go 3 units to the left, 3 units to the right. Okay? That's the value of d. Along the y-axis, which is the minor axis, I'm going to travel 2, because the denominator was 4 and the square root of that is 2. So from the center, I'm going to go up 2 and down 2. And this will help me create my little rectangle. Okay, so I'm going to draw it very lightly. You should too, because technically this rectangle isn't part of the hyperbola. It just helps us graph the hyperbolas. Okay, now the asymptotes are going to be, they're asking us for the asymptotes. I'll come back to all this information in a second. The asymptotes always get plugged into this equation, but you're going to need the slope um, that connects the kitty corners for this rectangle. So imagine a line, right, that passes through here and here. I draw them as dashed lines because asymptotes are not really part of the graph. They're imaginary lines that your function or equation approaches. Okay, so remember we said this has to open kind of like the x-axis, right? Left to right. So what you're going to do is you're going to draw a sideways parabola that goes through the vertices, and you're going to follow along the vertical or the diagonal asymptotes without touching them. Just make sure they don't look like a V, okay? So it has to be as curved as possible. So I could have done a better job here of making it curved. But yeah, that's the actual hyperbola. They look like two sideways parabolas. Okay, so let's make sure we fill in our values. So the vertices means that you got to change the x values because that was the value of D. So look at your vertices. You can actually just read them off the graph. So it's 3, -3. So remember, we're only changing the x values by plus or minus 3. So 0 plus 3 is 3, 0 minus 3 is -3. And you can see that those are the vertices, 3, -3, and -3, -3. The co-vertices, again, you can just read them off your graph. You had to go up 2 and down 2. So the y values changed this time of the center. The x stayed the same. But again, you can just read these off of your graph. So 0, -1, because you're adding 2 to the original y value of the center. So remember, this is like your base point. Okay, you're going to add 2 and subtract 2. I feel like this shifted a little bit. Okay, add 2 and subtract 2. So we're at 0, -5. Okay, so the foci, remember those are on the major axis. The major axis is the x-axis. So we're going to add root 13 to the x values, okay, to the x values of the original center. So since it was just 0, when I add 0 plus root 13, I get root 13. And when I take 0 minus root 13, I get negative root 13. Oops, typo. That should be a -3 because we're only changing the x values of the center. All right, and the equations of the asymptote, so what you're going to put in here are the ordered pairs of the center, okay? So the x value of my center is 0, the y value is -3, and then the slope, you can just count it from the center. I went, so you always use the center. I went up 2 over 3. So I'm looking over here, up 2 over 3. That's the slope, rise over run. And then, so that I'm going to highlight here. So this guy has a slope of 2/3, and then this one has a slope of -2/3. So that's why the plus or minus is necessary. And then you just want to clean it up. So You shouldn't have double negatives, so your asymptote would be y plus 3. And like I said, there's two slopes here, a positive 2/3 and a negative 2/3. And then your x minus 0, which technically, when you subtract 0 from x, you just get x. So you can even just write it like this. Okay? You do not need to solve for y, so you don't need to put this in slope-intercept form. I know that some of you remember doing that, converting point slope to slope-intercept form, but you don't have to do that. You can leave it in point slope form. Like I said, I don't even mind if you leave it with the 0. Okay? All right, let's try another example. Remember, you're more than welcome to pause and play the video at any point. Okay, so for this example, we have a different major axis. So our major axis now is going to be the y, because that is the fraction that does not have the subtraction in front. So your major axis is the y-axis, and that gives you the value of d. So that means d is plus or minus 3. The minor axis is going to be the x-axis, because that's the one that has the subtraction sign. That's the fraction, right? That has a subtraction in front. That's going to be the x-axis, and that's going to give us the value of e. So e is plus or minus 2. Okay, so what is the center of this hyperbola? If you said 1 comma 2, you made a little teeny tiny mistake. So remember that here they gave you the y value first, so it's actually 2 comma 1. That's really important, okay? So just watch out, because remember, the order could switch. They could give you the x first or the y first. You just got to pay attention. So I'm going to go ahead and plot the center of 2, 1. Okay, now I need to kind of build my rectangle and the diagonal asymptotes in order for me to graph the hyperbola. So along the y-axis, which is the major axis, I'm going to follow, right, what my value is for d. So I'm going to go up 3 and down 3. From the center, I'm going to go left 2 and right 2, because that was the value of e. So along the x-axis, you're going to go 2 to the left, 2 to the right, and very lightly draw your rectangle. Okay, because technically, remember, the rectangle is not part of the hyperbola. Okay, the next thing you're going to do, and feel free to start like writing out your vertices and your co-vertices. So the vertices are, I'm just going to read them right off the graph, are 2, 4, and 2, negative 2, which makes sense because only the y values should change if the major axis was the y-axis. Okay, so compared to the center, the vertices, only the y values should change because the major axis was the y-axis. Okay, the co-vertices are when I went left 2 and right 2. So that's going to be 4, 1 and 0, 1. So you're going to add 2 to the x value of the center and subtract 2 to the x value of the center, since x was the minor axis. Okay, so this is not enough for you to be able to draw your hyperbolas, okay? Now you're going to, through the kitty corners, you're going to draw, oops, started off kind of weird there. Draw diagonal lines, and these are going to kind of determine how wide the hyperbola is, okay? It's going to take some practice drawing these because they're not always going to come out straight. Okay, so since the fraction that was positive was the one with the y, that means it's got to open up or down. So now you are going to draw your hyperbola using your vertices and your asymptotes. Remember, asymptote, part of the definition of asymptote is you can get really close to it, you just can't touch. Okay, and then for the foci, you want to use your equation. But since we're using the same values for D and E in this example as the previous one, we're going to get square root of 13. Just so you know, though, it's not always going to be square root of 13. So the foci and the vertices are always on the major axis. So that means you got to add the root 13 to the y values of the center, okay? You're going to add, so you're not going to change the axis because the major axis was y. So you're going to add root 13 to the 1. You're going to subtract root 13. Now feel free to actually put that in your calculator. What is 1 plus root 13, and change it to a decimal. But you don't really have to. You can leave it like that. Okay, now the asymptotes follow point slope. So this is a general form. You're going to put the y value of the center. So that's, remember, these two are from the center. You're going to put the x value of the center. And then you need the slope of the diagonal lines. So I just count from the center, rise over run. So I'm going to highlight it in green. So rise over run. You could pick any 2 points that are on that dash line you drew. So rise is 3, run is 2. So that'd be 3 halves. And that's pretty much how you can leave it. The only thing I get picky about is I don't like having double negatives. So you shouldn't have like y minus -1. You would need to change that to a plus.